In section 2.5, we have quite a few more formulas, so I'll give you some examples on how to use those. Okay, let's try this example. We want to use a double angle formula to rewrite this expression. So I've got quite a few double angle formulas, and I'm going to look through them and try to find one that's kind of set up the same way as this one. Two of them involve cosine squared, but one of them also has a sine squared, so I don't want that one. I think that we can try to use the one that says cosine of 2u equals 2 cosine squared u minus 1. Let's see if we can get our expression to sort of look like the right side of this equation. So it doesn't, because the numbers that I have are different than the 2 and 1 from the formula. So in order for that 1/6 to be a 1, like if I divide it by 1/6, that would make it a 1. And we could see what it would do to the 1/3. Since this is not an equation, where our division is going to show up as factoring. So we're going to factor out 1/6. So to figure out what's going to go inside here, I'm dividing 1/3 by 1/6. So that means I'm going to flip the second and multiply, and this does give me 2. So 1/3 divided by 1/6. If I factor out the 1/6, what's left over would indeed be 2. So I've got 2 cosine squared x, and then 1/6 divided by 1/6 just gives me 1. So now that I've factored out the 1/6, what I have in parentheses does match this formula. So what I have in parentheses is going to be equal to cosine of 2u. So the 1/6 is still there, part of my answer, but the rest of it is just cosine 2u, and in this problem we're using x's, so we're going to call it cosine of 2x. Next, let's see if we can find the exact values for sine, cosine, and tangent of this angle 75 degrees. So the instructions tell us to use half angle formulas. So let's look at the half angle formulas. Okay, so I want to find sine of 75 degrees. And if I'm using a half angle formula, this 75 degrees is already the half. 75 degrees is the angle divided by 2. So that would mean that the angle is twice as much, so that would be 150 degrees. So u in this formula is 150 degrees. And the formula has plus and minus, so I do have to decide whether I want it to be positive or negative. So I'm going to consider what quadrant 75 degrees falls into. That's less than 90, so it's in the first quadrant, so sine is going to be positive. If u over 2 is 75 degrees, that would imply that u is times 2, so 150 degrees. So when I'm filling in this formula here, I'm using 150 for u. Now we need to evaluate this. So let's get the cosine of 150 degrees. Reference angle is 30 degrees. Cosine of 30 degrees is the square root of 3 over 2. So we are in the second quadrant, so cosine is negative. So this is going to be a negative square root of 3 over 2. Well, let's try to simplify it a bit. So we need a common denominator, so I'm going to rewrite 1 as 2 over 2. I'm going to make that minus minus a plus. And then all of that is over 2. So that gives us 2 plus the square root of 2 over 2 over 2. And dividing all of that by 2 would be flip and multiply. So multiplying by 1/2. I'm going to back it up here because somewhere my 3 turned into a 2. So let's go all the way back. And I would just leave it this way unless there were some reason that you needed it simpler. This is exact. So next, let's do cosine. Again, 75 degrees is in the first quadrant. So cosine is going to be positive, and we're using 150 degrees for u. And so again, evaluating the cosine of 150 degrees and cosine 150 degrees is negative. So this time we get a 1 minus the square root of 3 over 2 all over 2. And if you can use enough parentheses to enter your answer this way, so that website understands it, you can leave it this way. But it's probably a little bit simpler to divide both things by 2 and write it this way, just minus. Now for tangent, we'll use just one of these. We'll use just one of these expressions for tangent of 75 degrees. I'll just go ahead and use 1 minus cosine of u over sine. Right, so we just need to evaluate cosine of 150. And cosine of 150 is negative. And this time we also need to know sine of 150. In quadrant 2, sine is positive, so it is a positive 1/2. So I've got 1 plus the square root of 3 over 2 divided by 1/2. Dividing by 1/2 means to multiply by 2, so I'm going to get 2 plus the square root of 3. Okay, so let's use one of these formulas to solve an equation. So we saw in section 2.3 how we would solve an equation that involved a double angle or a half angle, so any multiple angle. But in those cases, we only had one function, and we were able to isolate the function so that it was just one function on one side of the equation. And sometimes, such as in this example, there's no way for us to do that. There's no way that I can combine these two cosines together because the input is different, so they're not like terms. I can't add them. So this is a good time to use a double angle formula to rewrite that cosine of 2x. So the formula that I'm going to use is going to be one of these. And to decide which one, it may take some trial and error. So you may try one and, if you get stuck, then try another one. Some things that I'm thinking about when I'm trying to decide which one is that I want to isolate a trig function so that I can solve for x. So maybe I don't want to introduce sine. It might be easier if they were all cosines. So I'm going to try to use the second one that only has cosine in it. Yes, it's a problem that is square, but that might be better than having the sine squared in. So I'm going to replace cosine of 2x with 2 cosine squared x minus 1. And then I'll still have the plus cosine x that was there. So now thinking about the ways that I could solve something that looks like this, looks like a quadratic. So maybe we can try one of our methods for solving quadratic. We can try to factor or use the quadratic formula. So I'm going to arrange these like this. Remember, if you want to factor, one side needs to be 0, so I'm not going to move anything to the other side of the equation. But I'm thinking if I could factor something that looks like this, you can use the AC method. You can kind of just guess and check. This one indeed does factor. So I know I need a 2 cosine times cosine. The only options for 1 are 1 and 1. Let's see if this is positive and this is negative. 2 cosine times cosine gives me the 2 cosine squared. The negative 1 times the positive 1 is negative 1. So now I'm just going to double check these and make sure that they add up to cosine. So this is negative cosine. This is positive 2 cosine. When I add those two together, I get 1 cosine, which is exactly what I need. So that's how it factors. Perfect. So now that it's factored and the right side is 0, I can split up the factors. So I can say 2 cosine x minus 1 equals 0, and cosine x plus 1 equals 0. Solve them separately. So trying to get cosine by itself. Over here, I'm adding 1. Don't forget my x. And then I'm dividing by 2. So cosine x equals 1/2. So cosine is equal to 1/2. In the first quadrant, it happens at pi over 3. And then cosine is positive again in the fourth quadrant, so that would be 5 pi over 3. So pi over 3 and 5 pi over 3. And then over here, just one step, so subtracting 1, we get cosine x equals -1. Cosine, the x-coordinate, is -1 and pi. So when x is equal to pi. All right, so the three of these give us our solution. And we should double check. We should plug these back into the original equation for x and make sure that everything stays true. We don't get anything that's undefined or that doesn't work out. But these three do work, so that is our solution.